Our second live session. Today we are going to go through some updates on our technologies, and specifically Cyclone and Zenoh. So let's just get started, and let's get started with Cyclone DDS. So first of all, what are the latest features that you should be aware of? Well, in Cyclone DDS we have C++, Python, and C# API. C# API, which is obviously maturing and will be completed coming next. X types. So they've been evolving, but there are more features. And by the way, we've recently added some support for X types even in ROS 2. Security, zero copy optimization, by the way, with some refactoring that now will make it possible to plug multiple implementation for zero copy and in general transport. TSN support, which is a feature that has been asked for quite some time. So TSN support is already there, pretty straightforward to use by configuration on Linux. Monitoring tool. So that it is our NetLens tool that has been now available for a couple of months. And again, we keep improving the performance, the robustness. This is really the landmark of our product. What is coming up? So coming up is a very important update, durability service. So some of the key components of that service are already in place as I speak. And they will be just finalized and released sometimes later this year. Static discovery, so obviously that's one of the preconditions to then support certification and a certifiable system with Cyclone DDS. And as you will have noticed from our GitHub, the team has been working on making the code base MISRA-C compliant, which is quite some endeavor, but an important point, once again, for automotive certification and in general certification in other domain. What we will be doing next, as I explained yesterday during the Zeta platform launch, is that we will have a single entry point for all of our tools. And as you saw yesterday, you can visualize the topology of your system. And depending on where you click and depending on the technology that is used in that subsystem, you will be able to use the tool associated with it. So we're working on integrating NetLens in the Zeta platform, and what that will make it possible is for you monitoring and managing a DDS system essentially from anywhere. So suppose you have a robot running ROS with Cyclone DDS and you are teleoperating this robot. Something is not working as expected, perhaps you want to see, you want to dig in the DDS information bone. Well, you will be able to do it through the Zeta platform from anywhere. Either by being by the robot or by being across the globe. And then obviously big things, Q1 2024, we will have our certified version. Okay, let's move now to Zenoh. Quite a few additional Zenoh has been very active in the first few months, so let's see what's up. First of all, Universal C++ API. What does that mean, really? Well, it means that with our C++, and in fact, even with our CPI, you can write your application once, and then at compile time, decide if you want to compile for Zenoh Pico, which is the embedded version of Zenoh targeting microcontrollers, your favorite microcontroller, or if you want to target the full-blown Zenoh. Okay, and that's great because all of a sudden you just have one API to learn. C or C++ doesn't matter. It is a compile time that you decide through a pretty straightforward CMake configuration what you want to target. Second feature that now has been stabilized and we've released literally 2 weeks ago is the query payload. I will get a little bit more into the details of what is the query payload, but that was a feature that we have been promised for some times and was highly requested. So we'll understand a little bit more what that does and why that is so important. We have now full MISRA-C compliance for Zenoh Pico, so that's in place. Key formatters. Key formatters are quite useful because in Zenoh when you write data, right, you usually write data associated with a key. Now, if you have a large project, how do you make sure that people don't misspell or misuse key? How can you actually kind of type check keys? Well, you can do that today by using key formatters. So you can actually define the syntax of your or the language associated, the regular language associated with the key in your domain, or the set of regular languages, And then whenever you write some data, use a key formatter to be sure that what the key that you're using complies with your key space. So that's quite useful. And there are some other nice additions with respect to building and doing a key lookup. Transport protocol whitelisting, I'll get onto that later, so this is one of the features I'll give you a little bit more information. Something else, again, that was highly requested by the community and is now in is notification API for connectivity. So now you are notified, or you can subscribe to be notified when you connect or you open a session, and by the way, on the status of that session. Something else that we've implemented is liveliness assertion. And again, this is something in which I suggest you read our blog on it, which is coming up. But there is already some information on the latest release blog. But this is quite an important feature in two ways. It is important because it allows you to understand when within your system some elements are still around or not, and which is a useful feature. Obviously, before, for those of you that perhaps have used some of our extension as part of Zenoh X, we had that built as a group management and didn't have any protocol support. As a consequence, we couldn't be necessarily optimal on the wire. So what this liveliness assertion has done is that makes liveliness built in the protocol, built in the routing, and so we can support liveliness with incredible scalability and almost zero overhead with respect to traffic, which is, I think, quite an achievement. So now you can use this feature without necessarily worrying of the impact on network traffic, which is great. Other important feature is transparent compression. Again, we have published some information. You can really dash down the size of the packet that you're sending on the network, especially if you have not so very high entropy data. And that's completely transparent. Mutual TLS authentication, again, a feature that has been asked by the community for quite some time, along with now support for Let's Encrypt and IP-based certificate. Once again, feature that you guys have been asking on Discord are there. But we're not done. So I'm getting tired of reading the list, but I think that's a good news as there are so many new features. Once again, as the community had asked, we now have released a ROS1 plugin. This ROS1 plugin brings all the power of Zenoh to ROS1 or ROS user. So you can use it for R2X communication, as we will see, and a few other interesting things. Something else that we have done, as there are more and more companies deploying our Cyclone and Zenoh side by side and using our DDS ROS2 plugin for R2X, we've improved its performance and, more importantly, introduced the possibility of doing zero copy. Once again, I'll give you some more information on that because that's a very important update. We have released the MQTT plugin, and we'll see what are the implications of that. Improved our Amazon S3 plugin, and Python documentation asks quite a bit of more information, and I would say to the level of the Rust API, which is pretty well documented. So let's dig into some of these updates. Query payloads. So let's start with one example. So suppose that I'm building some automotive application or robotic application, in any case a distributed application, in which at some point I need actually to get some classification on an image. Okay, so I'm a car and I'm offloading. This is a typical use case of edge automotive. I will do some of the detection on board, but some of the more advanced detection, computer vision, will be done by some edge infrastructure. So people that use Zenoh usually model that as a queryable that sits somewhere, and the device then just do a get, triggering the queryable. But in order to analyze the image, I need to pass the image. And originally, when you were issuing a query in Zenoh, the argument could be passed only as part of the key. So if you wanted to send an image, you could, but that meant that you had to base 64 encode it, for instance, which isn't great. And so with I have the animation here. Yeah. Now, with the support for the query payload, what it means is that when you do a query, you can attach an attachment, a payload, associate a MIME type, so in this case will be an image MIME type, and let the queryable that is triggered by that query retrieve the payload and do something with it before replying. Using it, it's pretty trivial. I mean, this is a full application that uses query payload and query. You see that here we are opening a file where we retrieve the Zenoh logo, open a session, and then issue a GET on a key, and this is our attachment, okay? And then we just wait for the replies, okay? And here you have the queryable, in which essentially we open a session, declare a queryable with this callback, and what the callback does, whenever it's triggered, it analyzes the payload of the query and then replies with the classification. In that case, we'll reply, it's a drama. Okay, so let's move next to the MQTT plugin. Once again, this is one of the features that was very much used. We have quite a few users that have existing system using MQTT, which are suffering from scalability and throughput issues. What is usually the problem? The problem is that in MQTT, you typically have a broker that is deployed on a cloud, and so you have to suffer the round trip to get to the cloud. You have an hub-and-spoke architecture that is hard to scale. You have usually to stick then to proprietary technology in order to be able to scale some of this broker. And in any case, you have very limited flexibility on how you might deploy your system. With a Zenoh plugin for MQTT, the good news is that now you can actually deploy your broker wherever there is a Zenoh router. And as we saw yesterday, you could actually provision that through our Zeta platform, right? That means all of a sudden that you can bring the plugin, you can bring the broker as close to the application as you want, and then let Zenoh route data between them, which is great. But if that wasn't already sufficiently good, then now the entire Zenoh ecosystem can be leveraged from this. So all of a sudden you can store MQTT data in Zenoh storages, for instance, right? You can have interoperability within pure Zenoh application like this one and MQTT application, which means that if you have legacy using MQTT and you have scalability problem, you can already solve this way. And then if you want to fully leverage Zenoh, you can start writing bit and piece of your application in Zenoh because you have interoperability. ROS1 plugin. Okay, ROS1 plugin. So this was something highly requested during the ROS conference in Kyoto. You know, we have done it for you. And I'll tell you what it's in place. What are the limitations? Because there are certain things that we need to solve, and we are discussing this within the ROS community. And you know, what's the plan for next? But first of all, through this plugin, as we do with the ROS2 or DDS plugin, you have the full leverage of Zenoh for robotic application and R2X. And this is an example where obviously you can use this plugin to have a swarm of robots communicating or doing teleoperation and so on and so forth. It has transparent interoperability with Zenoh application. We have demonstrated this several times for the ROS2 plugin. The same applies obviously to the ROS1, to MQTT. I mean, that's just a feature of all of our plugins. And it gives you a path for ROS1 to ROS2 connectivity, which is super important because there are lots of companies using ROS1. And the challenge is that how do you manage, for instance, a swarm of robots that mix ROS1 and ROS2? Today it's a big challenge because they cannot communicate, there is nothing that can easily bridge. And by using our ROS1 and ROS2 plugin, you can do that. And there are some other things that you can do that we'll explain through our data flow framework. But let's say that the building blocks are there. What are the limitations of the current plugin? Well, the limitation isn't really a limitation on our side, but it's more an issue with the Rust binding to ROS, which has some performance issues. We have raised those to the community, and again, we will see if the ROS team will take it on. Otherwise, we will definitely give an end to address those performance issues. But let's say that the Rust binding to ROS today is below optimal. Okay, let's move now to zero copy. And let's see why this is so important for the ROS2 and DDS plugin. So as of today, we have lots of users using Cyclone as an RMW to ROS2, and in fact that's probably the most widely used DDS implementation for deployed systems. And then they leverage Zenoh for robot-to-robot and in general teleoperation. Okay, so this works very nicely. Quite a few companies have deployed this as is, and so you might say, why, if it works, why change it, why touch it? Well, because the issue here is that although it's pretty this integration is very high performance, but still you are going through the Cyclone stack and the Zenoh stack before getting data out. Once again, the latency introduced is marginal. The throughput that we can achieve is way more than you would ever have to deal on a robot. So, I mean, on theory, that should be no problem. But even if it's not a problem in terms of latency or throughput, that takes some CPU, right? And so, in order to provide you the ability of, first of all, reducing the latency when you are sharing large data, suppose you are sharing images from time to time, and reducing the processing time, we've introduced a zero-copy optimization between Cyclone and the ROS plugin. So now, whenever you enable zero-copy, there is in fact zero overhead when using Zenoh for R2X and receiving data from DDS, which is quite nice. And that means that now applications that require very low latency, when integrating with the MCUs, okay, we have more and more people using Zenoh Pico as opposed to MicroROS because they find that it's more performant, more efficient, and that the API is far easier to use. So now all of a sudden, even on a latency critical application, this becomes a very viable solution. Although we had a use case that we're using this deployment even with microcontroller, I mean this one, okay. Now this is just perfect. But there is more coming. Our ROS1 bridge already leverages, for instance, Queryable to map services and action. We are going to do that in the ROS2 or DDS plugin 2, because that will further slash the discovery overhead. And essentially the other point that I was mentioning before is really trying to engage the ROS community to optimize the ROS binding. And this leads to a question. In the ROS community, and even on our Discord, people keep asking, when will we have an RMW for Zenoh? And my point is, do we really need an RMW for Zenoh? And is that the right approach? So let me try to explain what I mean with that. So the plugin that we have made, right, in terms of runtime overhead, essentially has zero runtime overhead because of the zero copy. At the same time, having the ability of dealing with a plugin that can control the data that you expose outside the robot, can do QoS changes in a way, can do downsampling or downrating, gives you a way of controlling at a very fine, in a very precise way, how you expose data outside of the robot, which is quite important because in our experience sometimes we have some information produced within the robot that doesn't need to be exchanged exactly at the same rate outside of the robot. And so having an integration point make it easier, and then if this integration point has zero overhead with the RMW that you're using, even better. And the other point is that, I mean, this is there now. Doing RMW would be quite a bit of work, and I'm not really sure that in the end, we would gain immensely compared to the effort that we would have to put in. So I think this solution is now equivalent to a Zenoh RMW plus the extra advantages that you have in terms of control on how to expose information to the rest of the world. So let's keep moving because, again, there were quite a few updates in the last release. Protocol whitelisting. What is this about? So in Zenoh we support tons of protocols. As you know, we can sit on top of a data link, and very often we have application on embedded system running on serial, Bluetooth, on OpenThreadX, And then applications that communicate perhaps over the internet, they would use sometimes TLS or QUIC or WebSocket. And the point is that when you deploy an infrastructure, sometimes you want to be able to control on a given interface which protocol you allow. And in previous releases, you would have to do that by deciding what you were compiling in and compiling out, which is not very flexible, because if you change your mind, then you have to recompile. And today we have a new configuration that allows you to decide which protocol to expose for which interface. And so in this small example, you see that, for instance, this application is whitelisting only TLS. So someone trying to connect through TCP/IP or to open a session over TCP/IP won't succeed, will be rejected. And this one is whitelisting TLS and TCP, so in this case, obviously, we'll be able to communicate through TCP with that other application. And when would you do that? You would do this, for instance, because this application is communicating only across the internet, so you want to make sure that security is used, for instance. But the same could be true if you wanted, let's say, to limit communication to Unix socket or serial or whatever. So you decide the list of protocol that you want to support per interface. Okay, so what's coming up? QNX support. And QNX support for Zenoh is already there. I mean here for the Rust version of Zenoh, because QNX has now support for Rust that was contributed by a collaboration, was implemented as a collaboration between QNX and Electrobit. So we are working on having a version of Zenoh for QNX. Zero copy transport. We already have, this is already implemented. We are just validating performance and will be part of our next release. Some zero copy shared memory improvements. We'll describe these in details. We already have zero copy, and there are some improvements that we want to make that will, in a way, provide a more efficient and robust distributed garbage collection for the shared memory. For those of you that have not used Zenoh shared memory, it's automatically garbage collected. It leverages the Rust type system to do that. But there are certain things that we need to do to improve the garbage collection and make sure that on some corner cases, actually you don't end up leaking some memory. And some protocol improvements are also coming up. Then some additional ROS2 plugin optimization, so mostly leveraging querybles for services in action. We are building a JNI compatible API library for Zenoh, which means that, that will be used for our Kotlin binding, but anybody that fancy doing a Java or Scala or whatever could do that on top of the Kotlin binding or sit straight on the JNI compatible Zen API. Android integration and more documentation is coming up as well. Okay, so what's left for you to do? Well, join in, and join in on our Discord channels. So we will once again post the links to our Discord channel for Zenoh and Cyclone. We are there, our community, you cannot see them, but we are all here and as such there. The community is extremely supportive and welcoming, so don't be afraid. Join in and let us know how you like our product. Let us know the feature that we would like to see, and why not? Let us know if you're happy to contribute some feature, because we are always open to that too. So thank you very much, and as always, it's with patience, persistence, and perspiration that we can make an unbeatable combination for success, and that's what we do at ZettaScale. Thank you, and see you soon. Take care.